All right, so this is just a review video on how to build the unit circle in degrees and in radians. And technically this is on page 165 in your notebook. And here I've just kind of compiled some information that we calculated for sine, cosine, and tangent in a previous video that we did with the special right triangles. So I just have that information here as it's going to be helpful when we are putting our coordinates in the ordered pairs around the unit circle. All right, so this is a great review, or if you happen to be absent on the day we did this in class, this is a good overview of how we did that. So first what we're going to do is we're going to start labeling the unit circle in degrees. So we're going to label our angles, and starting at 0, sometimes it's easier to break it in sections. Like we know that up here this is a 90-degree angle, and a straight angle is 180 degrees, then 270, and all the way around the circle this could also be 360 degrees. All right, so then let's break this in half. So between 0 and 90 we have 45 halfway, and then add 45 to 90 we get 135. Add 45 to 135 we get 180, and then add 45 to 180 we get 225, then 270, and then 270 plus 45 is 315. Okay, so here we have all the multiple angles of 45 degrees. Then what we're going to do is we're going to label the ones that are left in multiples of 30. So this would be 30 degrees. This one is 60. We already have 90. After 90, if I add 30, I get 120, and then 150, and then 180. 180 plus 30 is 210, and then 240 plus 30 is 270, 300, 330, and 360. All right, so those are all of the degree measures that are important to us on a unit circle. And then we have to label in radians. So I'm going to just kind of put some steps here. First, label degrees. Okay, so do multiples of 45 first, and then do multiples of 30-degree angles. So then we're going to label the radians. Oops. All right, so with radians, a couple things that we know is if I have 0 degrees, that's going to be 0 pi radians. And all the way around the circle was 2 pi radians. All right, so for 0 and 360, we've got the radian degree measures. If we go halfway around the circle, we have pi radians. And halfway between 0 and pi is half of pi, which is pi over 2. Okay. So if I'm counting by halves, I have 0 halves, 1 half. This is 2 halves, or a whole. So down here, this is going to be 3 halves, or 3 pi over 2. Okay, so now we'll break it into quarters. All right, so, or break our halves into halves. So halfway between 0 and pi over 2, a half of pi over 2 is pi over 4. Okay, so if this is 1 pi over 4, 2 pi over 4, I'm looking at the multiples of 45 degrees now. This would be 3 pi over 4, and 180 is 4 pi over 4, which is just 1 pi. Then we have 5 pi over 4, 6 pi over 4, 6 over 4 is 3 over 2, and this would be 7 pi over 4, and 8 pi over 4 is 2 pi. All right, so then what we're going to do is we're going to break down our 30-degree angles, and if I want to change 30 degrees to a pi radians, remember I start with 30 degrees. I'm going to multiply that by pi over 180. That's a times. And I get pi over 6. Okay, so the rest of these angles, 30, 60, 120, 150, are going to be multiples of pi over 6. So this is 1 pi over 6. This is 2 pi over 6, or if I reduce, 2 over 6 is 1/3. This is 3 pi over 6. 3 over 6 is a half. This is 4 pi over 6, which is 2/3 pi. This one is 5 pi over 6 and 6 pi over 6. We already have that as pi. So this is 7 pi over 6, 8 pi over 6. So 8 over 6 is 4/3 pi, 8 over 6. Then we have 7, 8 over 6. This is 9 over 6, which is 3/2 pi, or 3 pi over 2. And this is 10 pi, so this is 11 pi over 6. All right, so here we have labeled all the way around the circle both pi radians and in degrees. All right, so now what we need to do is find our ordered pairs. Okay, so we're going to label all of these points around the circle. All right, so the easy ones to do would be the ones that are on the axes. All right, so this point right here, and if we remember, a unit circle starts at the center and goes to the edge of the circle. This is our radius, and our radius is 1. So this is over 1 unit up 0. So on our graph, it's over 1 up 0. So a 0-degree angle on a unit circle has the coordinates of 1, 0. 90 degrees, I'm going up 1, so I go over 0, up 1. This is over -1, up 0. And then I have over 0, down 1. All right, so let's now label all of our angles that are multiples of 45 degrees. All right, so I'm going to refer down to this chart, and I'm going to also remind us, and this is just kind of some steps I took, that we are looking at sine and cosine are the values in our ordered pair. So cosine of the angle, and it says here, is the x coordinate, and sine of the angle is the y coordinate. All right, so if I look at just these special right angles, or the special angles that go with the right triangles, for pi over 4, which is 45 degrees, my sine and cosine are the same value. They're both the square root of 2 over 2. So I'm going to just put this in here, square root of 2 over 2 for both my x and y coordinate. And for any angle that's a multiple of 45, they're going to have coordinates square root of 2 over 2, square root of 2 over 2. The only thing that will be different with the coordinates is the sign, and we'll talk about that probably last. All right, so down here, 225 was a multiple of 45 degrees, so this is also going to have square root of 2 over 2 and square root of 2 over 2. Over here in the fourth quadrant, I'm going to have the 315 degree angle, square root of 2 over 2, square root of 2 over 2. And again, we'll adjust the signs in a little bit. So now let's look at, let's do multiples of 60 degrees. So 60 degrees, if I look here, 60 degrees, sine is square root of 3 over 2. That's the y coordinate, and cosine is 1/2. So I'm going to have 1/2 for cosine and square root of 3 over 2 for sine. All right, so the next multiple of 60 is 120. It's going to have the same coordinates. It's going to be 1/2 and square root of 3 over 2. Okay. Down here, this is another multiple of 60, but we've already got that labeled. The next multiple of 60 is 240, so I'll fill in 1/2 and square root of 3 over 2. The next multiple of 60 is 300. This is 1/2 and square root of 3 over 2, and then I get back to the beginning. So now what I have left are just these multiples of 30 that are not multiples of 60. Okay, so it's the odd pi over 6 values, because the even pi over 6 values change to pi over 3. All right, so let's do those. And for a 30 degree angle, I'm going to look down here. Cosine is square root of 3 over 2, and sine is 1/2. Okay, so just kind of a thing to notice in here. For a 45 degree angle, these are the same. Sine and cosine are the same. And for a 30 and 60 degree angle, we flip the sine and the cosine values. All right, so sine of cosine is 1/2, where cosine of 60 was 1/2. Okay, and same thing for square root of 3 over 2. So the coordinates I'm going to put in my ordered pair are the cosine and sine. So I have square root of 3 over 2 and then 1/2. So if I go back up here, 30 degrees is square root of 3 over 2 and 1/2. Okay, now I'm going to go around, and in this quadrant, I have the odd pi over 6. This is going to be square root of 3 over 2 and 1/2. Then I'm coming down here to 210, square root of 3 over 2 and 1/2, and over here to 330, square root of 3 over 2 and 1/2. All right, so when we labeled our cosine and sine values in the ordered pair, do the 45 degree angle first, then do the 60 degree angles, and then do the 30 degree angles, the odd pi over 6 that didn't get filled in with 60 degrees. All right, so if you keep this pattern going around the circle, I think it's easier to remember. All right, so then I mentioned before that all of these angles that are multiples of 30, or all the angles that are 45 degrees have the same coordinates and the signs would be different. So what that means is I have a little mnemonic device here, and if I remember, I'm going to have all students take calculus, and this is going to help us remember what signs are positive. So in this first quadrant, everything is positive. All signs are positive. Okay, so all of these inside here are positive. In the second quadrant, only sine is positive, which means cosine is negative. Okay, and also tangent will be negative because that would be sine divided by cosine. So I'm going to go and I'm going to find all the cosine values, which, if I look down here, cosine is the x coordinate. So I'm going to make all these x coordinates negative. In the third quadrant, only tangent is positive, so sine and cosine are negative. All right, so here, all of these values are negative. And in the fourth quadrant, cosine is positive, which means sine is negative, and sine is the, what is sine? Sine is the y coordinate. So I need to make all of my y coordinates negative here. All right, so just what I did there in terms of putting in the signs. Oops, let's do this. Remember, all students take calculus. All students take calculus. All signs are positive. Only sine is positive. Tangent is positive. Everything else is negative. So sine and cosine are negative. And cosine is positive in the fourth quadrant and not sine. All right. So this is it. This is a good representation of our unit circle.